Hi, on our second video for chapter 24, we're going to look at the methods that use the time value of many. And the time value of many, you'll find it's in Appendix B. On B10 is the table using table number 1, and it's called the present value of a dollar. And on B11 is table number 3. That's the present value of an annuity of a dollar. And we're going to do some and we're going to talk about it. On table 1, you can always use table 1, but there are times when you have a long, even flow you wouldn't want to because it's going to take way too long. Number 2, you must use it on an uneven flow. And an uneven flow is kind of what we looked at one of the last chapters, where one year it was 10,000, another 40, then 15, then 90. So the cash flows that are of an uneven nature. We also have to use table 1 when some item occurs just once. So like if you have a piece of equipment and it has a 10-year life, and after 7 years you have to do a major overhaul that costs a lot of money, that would be an example of an item occurring only once in the life of an asset. Table 3, on the present value of an annuity, the only time that you can use table number 3, the present value of an annuity, is only when you have an even flow. So we've looked at some of those before too. So it's like every year they get in 20,000, 20,000, 20,000, 20,000, 20,000, then we can go ahead and use table number 3. I made a copy of them, and so we want to talk about them a little bit. This is table number 1. It's the present value of a dollar. Well, what we have across here are the annual interest rates. And of course, in actuality, there are lots of tables that have a portion of interest rates, 2.5, 9 3/4. And of course, they would go out much further, but this is sufficient for what they're asking us to do in the book and learning how to use them. Down here, we are looking at yearly periods of time. So that means if something lasts 5 years, we can go here. Something lasts 14 years, we can go here. If we run across one where they're talking about like semi-annual interest, so if they were looking at something that had a 5-year life, semi-annual, kind of like bonds, then what we do is we would cut and the interest rate was say 6%, 5 years semi-annually. Then we would cut that in half and use 3%, and instead of using 5 periods, we would use 10 periods, because if we think about it, we would have in 5 years with 6% interest, basically we would be getting interest then 10 times, and basically half of the interest per half year, or 3%. Most of the ones in the book simply are looking at annual interest rates. They only happen once. If you notice, as we go from 1% up to 15%, then the numbers get smaller as we go across, and that's because what we're looking at is we're trying to bring money back from the future to the present. And as we go down the columns on table number 1, the present value of a dollar table, we'll notice that these go down as well. And they go down longer, that you have to wait for money, the lower what we're looking at. Think of present value as the flip side of future value. And so, again, if you're trying to bring a dollar back from 40 years at 1% interest, it's not going to be worth an awful lot of money, and that's what happens. Down here at the bottom, it says use to compute the present value of a known future amount. For example, how much would you need to invest today, compounded semi-annually, to accrue $5,000 6 years from today? And I don't know why, but that sounds more like it goes to the future value table rather than a present value table, so we're just going to forget that. And what we're going to look at is something like the present value. So if something cost you $10,000 in 5 years, you want to bring that, or somebody is going to win on the lottery $10,000, and you're going to collect that in 6 years, and the interest rate on that is, say, 5%. Okay, so what you're going to do is we're going to go to 5% interest, go down here to, I think I did it opposite, 6 years at 5% interest, so it's 0.7462, and we're going to multiply that by the $10,000, and what that's going to equal is $7,462. So if what you are getting is $10,000 6 years from now, and the interest rate is 5%, these two things are equal 6 years apart and 5% interest. So if you were bringing like the salvage value back or something on a piece of equipment, when you do that, the salvage value in 10 years at 5% interest in 6 years, then basically the value of that is $7,462. So these two things are the same amount, 6 years apart at 5% interest. The other thing that we talked about, and I also made a copy of that, and that is the present value of an annuity. And I want you to notice something. Flip this one back over, okay? Notice here, if you look at one period and we look at it all the way across, they're exactly the same, okay? All the way across, all the way out to number 15% interest. They're exactly the same because all that table number 3 is, and this is our table 3, this is an accumulator table. So if I were to take my calculator right here, and I were to take my present value of $1 table, that's the one we looked at a minute ago, and if I put in my calculator 0.9901, which was 1 period, 1%, and I added to that 1 period, 2%, 0.9803, what I get is 1.9704. And where would I find that? I'll find that at 1% and 2 periods. And if I go back over here and I add to my 1.9704, I add my 0.9706, I'm going to end up with the same number that I have over here. And so all these is an accumulator table. It simply accumulates the table here. And that's why you can use table number 1 anytime. So if you have one thing that happened in 6 years at 5% interest, you could use this table. If you had something that was an uneven flow, so you had $5,000 in the first year, $10,000 in the second year, $12,000 in the third year, you can always use table number 1. If you had an even flow of $10,000 the first year, $10,000 the second year, $10,000 the third year, all the way up to $10,000 a year for 15 years, you could multiply whatever your interest rate is by the factors for all 15 years and then total all of that up, and you'd come out with a number. Or when you had $10,000 every year for 15 years, you'd be wise to just go over here to table number 3 in the book. At the accumulator table, the present value of an annuity, go to your interest rate, come down to the number of 15 years, find that one factor that basically is a summation, pardon me, of the 15 factors on table number 1 and multiply it by your $10,000 or your whatever your even flow is, and you save yourself a lot of time and come out with basically exactly the same number. So that's how we go ahead and utilize our present value of a dollar table and our present value of an annuity table, and you will find these in the appendix to our textbook. This one is on, as I said, this is on page B10, and this one is also in our textbook, table number 3, and it is on B-11 in our textbook. So what do we use these tables for? Well, we use them for those other things that we had talked about before, and one of them that they use all the time is basically the net present value method. And when you look at the net present value, and basically with the net present value, what we do is we get the present value of our inflows, and we subtract from that the present value of our outflows, and the difference between these two is our net present value. And that's what we're looking for to make our decision on, is this net present value. Okay? And so basically, if the present value of the inflows just equals the present value of the outflows, basically here our net present value would be 0. And we would accept this investment because it is earning the rate of return that we require. So almost every one of our projects, our exercises, problems, quick studies, or in real life, they will give you a return from their investment. It's either like they call it the hurdle rate, and lots of times it's a little bit higher than you think you could possibly earn out in the public. It's the cost of capital, because when you do these projects, you want to earn enough money to not only make money, but to have enough money to reinvest it at the end of its life as well. The second option is where the present value of the inflow is greater than the present value of the outflow. We would also accept this project. Why? Because it is earning a return greater than what we had required. So if we required 9%, it's earning greater than a 9% investment. So this would give us then a positive net present value. And ultimately, if the present value of the inflows is less than the present value of the outflows, we would reject this project because it is not earning the rate of return that we would be required. This one would give us a negative net present value. Now, remember that if you end up with something that has a negative net present value, it doesn't mean that it's not a profitable project. All it means is it doesn't meet your rate of return that you expect. So if you expect like a 12% rate of return and this comes out negative, it might be a project that someone else would be more than happy to accept if their rate of return would be like 10%, because the likelihood maybe at 10% it would become a positive net present value. So we're just going to take a look at a couple of our net present value methods here on our project. Okay, so Park Company is considering an investment that requires an initial payment of $27,000 and provides an expected cash flows of $9,000 annually for 4 years. So evidently we're in even cash flows. If Park Company requires a 10% return on its investment, what is the net present value of this investment? Okay, so again, what we're going to do is we're going to look for our inflows. And our inflow then, my nose is $9,000 evenly. And they told us up here that it's a 4-year investment and they want a 10% return on their investment. So what am I going to do? If I didn't stick them underneath, where did I put them? Because I need my tables. And I bet I put them, and I did, over here. Okay. So what I'm going to do, because this is an even flow, I'm going to go over here, and I'm going to use my table number 3, the present value of an annuity. Let me get it up here that we're looking at, and I'm going to peek back, and it is 4 years and 10%. So I'm going to go over here. Doesn't matter which way you do it. My nose, excuse me. My 4 years, and I think it said that it was 10%. And what I found on that table was 3.1699. So I'm going to come back over here to my problem, and I'm going to multiply that problem by 3.1699. Now remember, that was 10%, 4 periods on table number 3, the present value of an annuity. So when I multiply that across, I'm going to get $28,529. My outflow, I only had one, and the outflow was my initial investment, and my initial investment was $27,000. So when I subtract that, I get $1,529. Only if you can see it, if I could remember to move my paper up, and I do apologize. This gives me $1,529. So the present value of the inflows is greater than the present value of the outflows. So my net present value is positive. So I would accept this project. Okay. The second one we're going to look at is Quick Study 24-11, also net present value. Following information on an investment considered by Hudson Company. The investment has 0 salvage value. The company requires a 12% return from its investment, and they want us to compute this investment's net present value. So here is our initial investment. So basically, then we know that this is our outflow, and that outflow happens now. So the present value of anything that we're doing right now, the present value and its actual value is exactly the same. That's why up in our other one, we didn't do anything to it. These are our net cash flows, inflows for the year. We've looked at the inflows minus the outflows, and this is what we have gotten, okay, or our net cash flows. Here we have something that is uneven. So we're going to have to use table number 1. Excuse me. I'm going to pause for just a minute. I'm going to sneeze.